Hi guys, welcome to question number 8 of November 2023 AAHL paper 1. So this question is 9 marks. So I like these type of questions because they're integrations. Uh, so this is a 6 marker question, A part. So from this type of way they wrote the question, you can see that this obviously means that we have to use something called, there's way of integration called integration by parts. So basically, a way that I learned a normal way, and then I learned a way better way, which is a way I like to do it now, and it's mainly taught um, in JEE preparation, which is for the entrance exam for Indian Institute of Technologies, and yeah, it's a very useful method as for integration by parts. So I will now explain it to you guys. So it's like this. So there's this certain method that I first want you guys to remember this because this is like a order type of thing. So I'll show you the formula and what I mean by order. So I late. So I stands for inverse. L stands for log. A stands for algebraic. T stands for trigonometry. And E stands for exponential. Right. Okay. So now why we have to remember this? So this is because the formula for isolate or integration by parts is that we have to assign the variables first and second rank essentially. So this is our formula, which I'll write over here. Formula. Okay, so we have we have it like this and this. Okay, so this is the general formula. So it is number 1 into the integral of number 2 subtracted by the integral of the derivative of number 1 into the integral of number 2. And you take the integral of this whole thing. Okay? So, yeah, that's the formula. So let's now put this question into play. So, in our question, this x is considered as algebraic. And this ln is obviously log. So which letter comes first? Obviously the L comes first. So L comes before the A in isolate. So what's first? This is first. And this is second. So now let's just put this into the formula. So it'll become very easy now. So ln x whole square integral of x minus integral of d dy dx of the first one. dy dx of the first one we can do over here. So what is dy dx of ln x whole square? So this is quite simple. This we just take chain rule if you learned that in derivatives, but essentially it's you bring the 2 out. So in derivative is like this. So 3x squared, let's say you have a derivative. So you just bring the 2 here, 2 into 3x, then 2 minus 1. This essentially this is considered n, we can say. So then the formula is written as n minus 1. So this should be just 6x. So 3x squared. First derivative is 6x. So essentially we're doing the same thing here, but now in chain rule we have to do extra step, which I'll explain. We have 2 ln x, and now after we have the 2 ln x because also it's 2 minus 1, which is 1. So no need to write the exponent. 2 ln x, and now we have to take this is where chain rule comes in. We have to take the derivative of the internal portion only as well. So ln x का derivative क्या है? It is 1 by x. Okay, that should be memorized. So 2 ln x upon x. So now we can write it as 2 ln x upon x. And we know the integration of x, which is simply x squared upon 2. We know formula x, and this will become xn plus 1 upon n plus 1, right? So in our case, we have x raised to the power 1. So that is x1 plus 1 upon 1 plus 1, which is what I've written over here, x squared upon 2. So x squared upon 2 dx. Now what do we do? So we have ln x whole square. We have x squared here upon 2 from integrating this. Then we have the integration of 2 and 2 will cancel, and x will be left on the top. So this simplifies to x ln x. So now we have another islate because of x ln x. So x ln x, to take this integral, we need islate again, right? So when we need islate again, we assign the same thing. So this is first, this is algebraic, and uh, this is logarithm. So what comes first, like usual? This is first, this is second. So you put this in the same formula. Sometimes it will go to a point where it keeps repeating, and I'll show you one of those integrals later on in the JE videos, and it's a quite nice solution because you have to let it equal to I and all those things. So I'll show you how it is. So now in this basic one, we'll just bring this ln x. You put x minus of derivative of ln x, very easy, 1 by x into the integral of x squared upon 2. This is ln x into x squared upon 2 minus of x squared upon 2x. Now this will become x squared ln x upon 2 minus integral of x upon 2. So integral of x upon 2 is simply, you can remove the half and we can have x squared upon 2 into half is x fourth upon 4. So now we want to write our full answer, right? So in our full answer, we need to write it. This is where sometimes it gets confusing because you've done 2 islates and now you need to come back together and get the full answer. So obviously we started here, so we need that. So let me write this a little nicer. Full answer. Okay, that looks better. X squared ln x whole square upon 2. Now we have a minus x ln x, right? Minus x ln x. And we've only done integral of positive ln x ln x. So I'm going to put a minus here, and we can put it like this. And we have our integral right here, and yeah, okay. X squared ln x upon 2 minus x e power 4 upon 4. So this is now x squared ln x whole square upon 2 minus x square ln x upon 2 plus x to the power 4 upon 4. Remember plus c because this is the indefinite integral. So this should be our answer. Let me make this 2 a little bit down like that. Perfect. So x square into ln x whole square upon 2 minus x square ln x upon 2 plus x to the power 4 upon 4. And yeah, everything is right. Let me just double check my work. Oh, okay. One small mistake. I wrote 4 instead of 2. So yeah, that's what happens when you do calculus at almost 12 a.m. at night. So, okay. Yeah, now this should be correct. Yeah, this is correct, I believe. I think. Yeah. Well, you guys tell me in the comments if anything is wrong or anything, but yeah, I believe this is correct. So, yeah. And this is how you do part A. Now, part B. This is the easy one. 3 marks. So, part B. So it asks us hence show that, oh, it's given us the same integral, just made it a definite integral now. Okay, definite integral just when you plug in these numbers. Okay, this is really easy. Okay, so just getting a little bit into topic 1, which is the logarithms and number and algebra topic. So we already know integral of this, which we wrote. Now, if we get this correct, that means we got our integration correct. So if we prove this, then that means we got a part correct. So that'll be good. So x squared ln x whole square upon 2 minus x squared ln x upon 2 plus x square upon 4. Now I want to plug in 4 and 1. Okay, so essentially I plug in 4 square for wherever the x's are, minus of 4 square ln 4 upon 2 plus 4 square upon 4. Now I have to subtract it by the plugging it in to the 1, like this. Okay, so this is 16 ln 4 squared upon 2 minus 16 ln 4 upon 2 plus 16 by 4 is 4 minus, and this ln 1 is always 0. So this cancels and becomes 0, these both. So we have minus 1 by 4. So 4 by 1 minus 1 by 4. 4, 4. 16 minus 1, 15 by 4. So then now we have to simplify our logarithms essentially. So simplifying logarithm quite easy now. So okay, so okay, so I'm gonna think a little bit. Okay, so 8 ln 4, let's first do this, minus 8 ln 4 plus 15 by 4. So ln 4, we can write it as ln 2 squared, right? Now, according to log laws, this 2 will come out. 2 ln 2, hence. So this is now 8 into 2 ln 2 whole square minus 8 into 2 ln 2. plus 15 by 4. So this 2 can come out and multiply 8, as this is in front. This can also, but remember there's a whole square over here. Whole square means this becomes a 4. So we have 8 into 4, 8 into 4 into ln2 whole square. We have that minus 16 ln2 plus 15 by 4. So this is now 32 into ln2 whole square minus 16 ln2 plus 15 by 4. And that's our answer right there. So is that correct? Let's see. Did we get the same answer as what they're saying we should show? 32 into ln2 whole square minus 16 ln2 plus 15 by 4. Yes. So we got B part correct, so that means our A part's also correct. Alright guys, so yeah, that's it for this question. If you guys have any questions, then just drop them down in the comment box and I will respond. And yeah, please share, like, and subscribe and share this with your family and friends. Okay, thank you guys.